Okay, yo, we're trying to find out if this guy's lying. Turns out, guess what the answer is? He's lying, dude. So, okay, so here's what we got. Two cars heading towards an intersection. So car 1 and car 2. Car 1 is traveling east at 13 meters per second. And then car 2 is traveling north with some unknown velocity. They collide and stick together. Okay? The cars collide and stick together and move off at an angle of 55 degrees north of east, which is that way, right? North of east is up like that. Okay? The speed limit for both roads is 35 miles per hour. You got to convert this, right? Because look, this is in meters per second. So we got to get miles per hour. You want to convert that to meters per second, which I know you can do. That's 15.64 meter per second. Okay, the driver of car number 2 claims he was within the limit, so less than 15.6 meters per second. Is he telling the truth? All right, so we have a collision here. What do you think about when you have a collision? Momentum. Momentum is conserved in collisions. But what makes this problem trickier? Is it like a head-on collision in one dimension? It's a two-dimensional collision, also referred to as a glancing collision. So the problem's using north, south, east, and west. I find it easier to talk in terms of x and y, which is easy to do. Just convert north, south, east, west in your brain to x, y. So like east is positive x, west is negative x. It's easier to think in terms of x, y, right? Okay, so before the collision, do we have x momentum? Before the cars collide. Yeah, which car has the x momentum? Car 1 or car 2? Car 1. This guy has the x momentum. What is that x momentum going to be? Well, we don't know the mass of the car, but we do know the masses are equal. The two cars have equal masses. So what could we call this x momentum before the collision? Well, what's the equation for momentum? mv, right? We have the velocity, so I would just call this 13m, right? The velocity is 13, the mass is m, so the x momentum is 13m. Now, dudes, what's going to be the x momentum after the collision? 13m. The x momentum before the collision equals x momentum after the collision. So we have 13m in the x before and after. All right, now, is there y momentum before the collision? Yeah. Which guy has it? Car 2. This guy has the y momentum. So let's just put it in here. There's y. Notice I'm putting these tip to tail because that's how you add vectors. This is basically a vector problem. So we have y momentum before the collision. We have y momentum after the collision. And what do we know about those two y momentums? They're equal. But do we know what it is yet? Nope. But I'll tell you what we do know. Let me get my red out. So for total, the total momentum is going to be the hypotenuse. So this represents momentum total. So before and after, the momentum total is equal. Now they give us in the problem that the wreckage moves off at a 55-degree angle. So that's this angle right here, right? Now, dudes and dudettes, using your trig skills, can you figure out what this y momentum must be? Just using trig. Yeah. So how do we do that? So finding this guy right here, how do we find that dude? We're going to go tangent, wait, is it tangent? Opposite, yeah, tangent 55 equals opposite, which is our y momentum. That's what we're looking for. Let me put momentum y. Momentum y over adjacent, which is 13m. So you do the calculation. you find out that the y momentum has to be 18.566 m, right? Because we don't know what the m is, but it'll just be 18.566 m. 18.566 m. That's the y momentum after the collision, because we know the angle the wreckage moves off at. So what must be the initial y momentum? It's got to be the same, 18.566 m. So now we can figure out if the guy's lying or not. Oh, and he's lying, dude. He's lying. So how do we find out his velocity? So the whole thing is he telling the truth? Was he within the speed limit? So you go like this. We have the y momentum. So momentum equals mass times velocity. So we're talking momentum y, right? That's going to be velocity y before the collision. So his velocity is going to be momentum over mass. What was the momentum? 18.566 for the y. The m cancels out. So what must his velocity have been? The y velocity before the collision is 18.566. What was the speed limit? 15.6. You guys get it? Does this make sense? Any questions on this? So basically the trick was figuring out the y momentum, because once you have the y momentum, you can figure out what the y velocity was.